So good morning to everyone. So let's begin with lecture number 7. So this is evolutionary process 4a. So the thing is, evolutionary process 4 is divided into two things. So that is a implementation of switching circuits and detection system to the transmitter coil is divided into two parts. So I'll say why it is divided into two parts in the moment we actually go into the different slides, we'll understand. So this is the evolutionary process 4. So the thing is, irrespective of the excellent misalignment tolerance of the designs from sub-objective 1 to 3, there is enormous flux leakage that is actually mitigated using the switchable transmitter coils in this particular evolutionary process. Now you can see this design. This is one of the best designs that we have done. If you see the figure 51b, so here you can see there is a chief coil in the red color one, and there are the booster coils you can see in the blue one. So these two are independent coils, but there is a possibility of connection of these two coils also, so that we will discuss. So when the receiver coil, you can see in the figure 51a, is perfectly aligned with this transmitter coil, then only the chief coil will be excited to form a concentrated magnetic field to this receiver coil. Now the moment the receiver coil is misaligned, then what happens is the chief coil along with the booster coils will actually power up this the receiver coil to have a same amount of induced voltage. So that is the concept of this figure, this particular design in the evolutionary process 4. So in figure 52, I can clearly explain how the functionalities are happening. Now if you see the chief coil and booster coil, so when the switch is activated, if the switch is activated using a control circuit such as Arduino, then what happens is whatever current is passing through this chief coil will actually bypass the booster coils. So this becomes the mode 1 operation of the booster coil. That means under perfectly aligned condition, when the receiver coil is perfectly aligned, the switch will be actually activated. Then what happens is only chief coil will be powered. The moment, let us suppose, the receiver coil is misaligned, then what happens is this control circuit will open up the switch. The moment the switch is opened, then the chief coil and booster coils will be connected in the series so as to power the misaligned receiver coil. So this is the idea of the evolutionary process 4. So you can also go through the text which is written over here in meanwhile. So we have done a parametric optimization, you can see in the figure 53, sorry. So this is again using the same minimum mean square error algorithm. So we have done some optimizations. So the optimization process is similar to what we have done, so it remains same, the procedure is same, but the way is different. Now here you can see in figure 54, this is the layout of the proposed coil. There is a booster coils both in front and back side. So figure 54a, you can see this one. This is the front side part, that is the front part of the PCB. I don't say front, sorry, I'll say it's the top part of the PCB layer. So it is a double sided PCB. So in the top you can see the booster coils and the chief coil. In the bottom you can only see the booster coils. So booster coils are placed at the top and bottom layer so as to power same amount of magnetic field as this chief coil is powering. And figure 54c and e are independent modules. So figure 54c is only chief coil and figure 54d is actually a single module. If you see, there are multiple booster coils. If you take only one of the booster coil, so that is represented in figure D along with the dimensional values. You can also see what are the dimensions of the chief coil, what are the dimensions of the single booster coil, what is the total dimension. You can see it is only 200 by 200 millimeter, which is same as the literature design. So here we are not actually enhancing or the changing the maximum dimension of the transmitter coil. So now let us see the MATLAB results. So in figure 56 you can see the figure 56A represents the chief coil magnetic field distribution. Now figure 56B represents the combination of both chief coil and booster coils, so it is giving widespread uniform magnetic field. So that means in mode 1 operation, only concentrated magnetic field is generated when the receiver coil is perfectly aligned. The moment the receiver coil gets misaligned, then the magnetic field strength will convert from the concentrated magnetic field to the widespread uniform magnetic field as shown in figure 56B. The figure 56C is only for the sake of representation. This is the booster coil magnetic field distribution. If you add up figure C and figure A, you will get figure B, that is figure 56B. And figure 57 is the mutual inductance distribution under perfectly aligned receiver coil and misaligned receiver coil for both mode 1 and mode 2 operations. Figure 58 is the simulated analytical and measured results of the normalized H field, and similarly figure 59 is mutual inductance results of analytical and simulated results. So the most important thing what we need to understand is table number 7. If you see the uniform magnetic field region of the literature design, already I have shown in the evolutionary process 2, it is 51.84%, whereas the proposed SPDMC, that is the switchable planar multi-coil antenna, distributed multi-coil antenna, is 79.65%. A drastical improvement is there, and uniform mutual inductance region is also increased by almost I say 3 times. So 6 3s are 18.25, so almost 3.5 times it has been increased. So it is 23.04%. So figure 60, you can see this is the experimental setup, the same setup what I already explained previously. Now if you see the conclusive merits of the sub-objective 4, the misalignment tolerance is of uniform magnetic field region is enhanced by 53.06%, and uniform mutual inductance region is enhanced by 268.64%. And also if you see the S21 parameter of the proposed receiver proposed design is enhanced by 98 by 98 millimeter square compared to 52 by 52 millimeter square of the literature design. And also undesired magnetic field is controlled because of this dual mode configuration. But there is a disadvantage in this particular design that made us to actually go into the evolutionary process 4B. I already said, in evolutionary process 4 there are 2 designs. So why the 2 designs is, in this particular design we found out there is a small disadvantage. The disadvantage is because this is an unsymmetrical array. I'll just go back. Yeah. Now if you see this chief coil and this booster coils are not identical designs. Because of that, what happens is this chief coil resistance is different and the booster coil resistance is different. Now under mode 1 operation, what happens is, let us suppose the resistance is RC. RC is chief coil's resistance. Then your efficiency would be what? According to the RC, the losses according to RC. Although your mutual inductance is constant, you are maintaining in both mode 1 operation and mode 2 operation, but your resistance, that is RC and RC plus RB, are not same. In mode 2 operation, the resistance is RC plus RB. Because of this difference in resistance, the efficiency is going to be different for perfectly aligned receiver coil and for misaligned receiver coil. Irrespective, you are achieving constant induced voltage on both the conditions. So this made us to actually evolve further into the same evolutionary process to 4B. So that we will be discussing in the next lecture. So with this I want to conclude this lecture. Thank you very much.